So let's continue on our analysis. We are still on question 53. So having defined our worksheet, the share outlet as 116.2 degrees Celsius, we realize that once we come to performance, the duty has changed to 5.427 exponential 006 kilojoule per hour. So the answer to this question 53 is the duty is more than 5.2 exponential 006 kilojoule per hour. So from the analysis, having the LMTD of 118, we'll be able to get the duty of 5.427 exponential 6. So the duty is more than this. So our answer here is B. It's question B. So let's move to the next one, the next question. So having defined this and we've gotten your answer here, we'll go back to the simulation model and we input the formal figure that was there, which is 121.2. So we'll come back to our flow sheet, we'll change this one to 121.2 degrees Celsius. So we'll get our formal LMTD of 121.7 degrees Celsius. So the next question is question 54. Question 54. The question is the condensate and two phase critical temperature for the NGL feed stream are. Alright, the condensate and the two phase critical temperature for the NGL feed stream are. So how can we find the condensate and the two phase critical temperature? Alright, okay, in a simulation environment. We come to the NGL feed. We double click the NGL feed. Okay. Let's do analysis. Let's do envelope. Analysis, envelope, create. So take our envelope analysis, we'll add. So once you do your envelope analysis, this envelope dialog box will pop up. So from here, you realize that the two phase critical temperature is 171.5 degrees Celsius. While the condensed temp is 173.7 degrees Celsius. So from this analysis, you realize that the right option here is option B. It's option B. So the next one is, they say what's the mole fraction of C2 plus C3 in the propane stream? So how we can tackle this is we'll go to the propane stream, we'll get the mole fraction of C2, the mole fraction of C3, we'll be adding them together. After adding them together, we'll see which is the best option for it. So you can close all of this. We'll finish with the analysis. So you enter your propane stream, you come to composition. So ethane is C2, propane is C3. So add this and this together. Add this and this together. What do you have? Zero 0.0171 plus 0.9052. So what do you have there? You have 0.992 something. So the answer, the option falls between 0.85 and 0.95. 0.85 and 0.95. So what's the right option there? The right option is option C. So the next question is, what is the reboiler condenser duty? Reboiler and condenser duty of the depolarizer. So go to the depolarizer, the condenser duty, the reboiler duty, and from which we can tell what the best option is. So from here, let's enter the depolarizer. So this is the depolarizer. So let's come to performance. Let's come to condenser and reboiler. So from here, you can deduct or deduce that the condenser duty is 2.1. The condenser duty is 2.1 exponential 7, while the reboiler duty is 5.7 exponential 7. So from here you realize that the best option is what? The best option is option D, right? The condenser duty is between 2.0 exponential 7 to 2.25 exponential 7, and the reboiler duty is between 5.6 to 5.9 exponential 7. So D is the right option. So take note. So this is the way you'll be doing your analysis. But eventually, anything is changed in your exam. If the option is changed in your exam, you can deduce your answer like this. This is how you analyze your question. Then you get the perfect answer for it. It's not something you use fear and tension to just answer. So most of the time, they might change one or two things. They might still not change one or two things. But prepare and have it in mind that you must do some analysis. So if they don't change it, fine. But if they change it, there's no issue. Do your analysis, do your flow scheme, finish your model, then follow the question and do your analysis and get the right option and you move on. So the next question is The next question is, you are required to modify the process so that the light from the top of the column contains mostly ethane and propane. Add a new specification such that the mole fraction for C2 plus C3 in the propane stream is 0.98. The reflux ratio is still mainlined at 2. How does the flow rate of stream C4 plus change? Okay, now we'll be doing the analysis. Now we'll be doing the analysis in a way that when we add ethane plus propane, we'll be having 0.98 as the mole fraction of the sum. So the first thing we'll be doing, we'll be going to the depropanizer. We'll be going to the depropanizer. We're going to the depropanizer. So now we need to manipulate this so that we'll get a raise of C2 plus C3. So when we come here, we can't define it from here because this is a calculated variable. So we're going into the depropanizer. The depropanizer, we'll be going to the spec design monitor. Design monitor. So this is 1000. So we'll be changing this to, we'll be manipulating, we'll work on this bottom product rate. We'll work on this bottom product rate to the point that we'll get a C2 plus C3 of 0.98. So let's manipulate it. Let's change it to 15. So once we change to 15, it will calculate. So let's go to let's go back to propane. Let's go to the composition. So from here now, what will be the combination of the sum of C2 plus C3? So if you have a calculator here, you can punch it 0.0425 plus 0.9501. So I have a calculator here, so let me bring out my calculator. So we have 0.0425 plus 0.9501. So what we have here is 0.9926. So the question is, we should manipulate it to the point that C2 plus C3 of the propane stream is 0.98. So this one is 0.99. So we'll go back to our depropanizer. We'll come to monitor. Let's reduce this to 13 and see what the outcome will be. So it has resolved. Let's go back to our propane composition. So let's calculate. Here's the calculator. Zero point 0.026 plus 0.9655. Okay, we have to still manipulate it. Let's go back to the monitor. Let's turn to 1100.